All right, from today on, we're going to learn chapter 3, congruent triangles. So today is lesson 1 of chapter 3. We're going to learn the concept of congruent figures, and I'll give you the property of the congruent triangles. And next, we'll introduce how to determine if the two triangles are congruent triangles. Okay, first, let's have a look at the concept of congruent figures first. Okay, in two figures are congruent if they are exactly the same. In other words, we can slide, spin, and or flip one figure so that it is exactly on top of the other figure. Okay, so this is basically a intuitive concept of the congruent figures. So let's see a concrete example. So for example, if I have a pair of trapezoid here, and note here I can rotate the right one like this, and then flip it horizontally and translate it here, right? And as you can see here, this figure is actually exactly the same with the figure on the left, right? Can you follow me?
Yeah.
Then we call these two figures congruent figures. Understand? No matter how they are arranged, as long as you can put one figure on top of the other exactly after a series of sliding, spinning, or flipping, we can call these two figures congruent figures. Okay, let's see another example. For example, I have two triangles here, and if I can rotate the right one like this and translate it on top of the other one, and as you can see here, the right triangle is exactly on top of the left one, right? So these two figures, these two triangles are also called congruent figures or congruent triangles, right? And note that this point, so if you move this triangle, if you move the right triangle on top of the left triangle, these 2 points are called corresponding vertex. And this one, this vertex is correspond to this one, and this vertex is corresponding to this one. And also, this side is corresponding to this side, and this side is corresponding to this one, and this side is corresponding to this side. You follow me?
Yeah.
Okay, so let's have a look at some other examples of congruent figures. So for example, these two triangles look the same, right? As long as you can put one on top of the other exactly, then we call them congruent figures. And these two figures as well, if you can rotate one figure here, for example, clockwise, and then put it on top of the other one exactly, then we can call them congruent figures, right? And these two circles here look the same. And again, if you can put one on top of the other exactly, then they are congruent figures. And same thing happens here. If you can rotate one of the figures, and probably by spinning or flipping it, and if you can put one onto the other exactly, then we can call them congruent figures, right? So basically, in essence, congruent figures are figures that are exactly the same. Okay, next, let's have a look at the property of congruent figures. So in this chapter, we focus on studying congruent triangles. So the following discussion is based on congruent triangles. So the property of congruent triangles is the corresponding parts of congruent triangles are also congruent, which is abbreviated as CPC-TC. So for example, I have two triangles here, triangle DEF and triangle QPR, right? These two triangles are congruent, right? If these two triangles are congruent, first of all, we use this symbol here to mark the two congruent triangles. We use this mark here. We say triangle DEF is congruent to triangle QPR. So usually we'll write the triangle, write the vertex in an order. So triangle, because the vertex D is corresponding to Q, right? So we put D and Q in front. And if we put E in the second place, because P is corresponding vertex of E, so in the next triangle, we put P in the second place, right? And because F is corresponding to R, so if you put F in the last position in the first triangle, then you must put R also in the last position of the second triangle. So instead of triangle DEF is congruent to triangle QPR, we can't write like this. So usually we don't write it like this. You understand? Because vertex E is corresponding to P. So if E is in the second position here, you need to put P in the second position, not R. Can you follow me?
Yeah.
Okay. And if we know that these two triangles are congruent, we also know that corresponding parts of the triangles are also congruent. That means if I tell you that these two triangles are congruent, the corresponding values, such as angle D, the corresponding parts of the congruent triangles, for example, angle D should be congruent to angle Q, and angle E should be congruent to angle P, and angle F should be congruent to angle R, right? And also because this side is corresponding to this side, we know that this side should be congruent to this side, right? And because this side here, EF, is the corresponding part to side PR, so we know side EF is congruent to side PR. And also because DF and QR are also corresponding parts, so we know that DF must be congruent to QR. Understand?
Yeah.
Okay, any questions?
No.
All right, then let's have a look at how we can determine if two triangles are congruent triangles. There are 4 judgment theorems. First, let's have a look at the first judgment theorem, which is also called SSS. So why it is called SSS? So first, let's have a look at the theorem itself. If each side of one triangle is congruent to the corresponding side of another triangle, then the triangles are congruent. So for example, if I have two triangles here, triangle ABC and triangle XYZ, and we are told that AB equals XZ, and AC equals XY and BC equals ZY. That means each side of one triangle is congruent to the corresponding side of another triangle, right? If we have this information, we can say that these two triangles are congruent, which is denoted as triangle ABC is congruent to triangle XZY. The reason we don't write it like XYZ is because vertex A is corresponding to vertex X, right? And vertex B is corresponding to vertex Z. So if we put B in the second place, then you should put Z into the second place, right? And because vertex C is the corresponding vertex of Y here, then if we put C in the third place, then we should put Y in the third place in the second triangle. And also, if you want to, we should also put why these two triangles are congruent into the parentheses. So here, because we're using the SSS theorem, so we put SSS here to indicate that triangle ABC is congruent to triangle XZY by SSS. Understand? In other words, if you can prove each side of Y triangle, if you can prove if each side of one triangle is congruent to the other one, then you can say these two triangles are congruent, right? Okay, then let's have a look at an exercise. Okay, suppose we are given the following figure and the size and angle have measures as shown. Task is to find angle MLN. MLN is here. Okay, and I'll give you 1 minute to think about this question. So I'll give you a hint. It seems that if you can prove this side is parallel to this side, then this angle should equal to 25 degrees, right? Because if you can prove LM is parallel to this ON, then these two angles are just alternate exterior angles. Then they should be equal, right? So the key is whether we can prove these two segments are parallel or not. Or if you can prove this triangle, looks like this triangle is congruent to this one, right? So if you can prove these two triangles are congruent, you can also say that this angle should be equal to 25 degrees because they seems to be corresponding angles, right? Okay, I'll give you 1 minute to think about this.
I don't know.
Okay, let me ask you a question. Can you prove this triangle here is congruent to this one? Well, it seems that these two triangles are the same, right? But can you prove that they are congruent?
Because the 17 LM is equal to ON.
17 equals 17, right?
Yeah, and 9 equals 9.
Equals 9. So we have two sides that are equal, and they share the same side here, right?
Yeah.
Okay, so what can we write here? Because LO equals MN, right? NM. and ON equals ML, and also LN equals NL. So that means we have each side of one triangle is congruent to the corresponding side of the other one. Then the two triangles are congruent, right?
Yeah.
Therefore, we can say triangle LNO is congruent to which one?
LMN.
LMN. But I just said you should put the letters in an order, right? So what is the corresponding point to L in the red triangle?
L.
It should be N, right?
Oh.
Why it's N? You see that?
Yes.
If you cut this triangle out, let me show you how do we find the corresponding vertex. If you cut this triangle out and flip it, if you rotate it counterclockwise, this point should be corresponding to this point here, right? You see that?
Yeah.
So vertex L should be a corresponding point to vertex N. So you should put N in front. So what is a corresponding point in the red triangle of vertex N in the blue triangle? Okay, let's cut this and rotate it here like this. Then we see that the red triangle here, red triangle here is congruent to the blue triangle here, right?
Yeah.
So L is corresponding to which point?
N.
N, right? How about O? O is corresponding to which point?
M.
This one, right? M. And
But isn't
how
that
about,
what I said before?
okay. So can you tell me now, what should I put here?
I said M was congruent to O.
All right, then we say angle LNO is congruent to triangle. How do you say that?
LON. I don't know.
L? No, we just talk about L is the corresponding part to N, right?
O
So
N.
the first letter should be N, right?
M. O.
And
O.
why is O? No, this point must be in the red triangle.
N. O. M.
Should be L, right? Can you see that?
Yeah.
How about O? O is corresponding to which vertex in the red triangle?
M.
M, right? So we should write triangle LNO is congruent to triangle NLM. Understand?
Yeah.
So can you see the difference?
Yeah.
LMN and NLM. Can you see the difference? Each vertex in the second triangle should be corresponding to each vertex in the first triangle. You get it?
Yeah.
Okay, so that means if the blue triangle is congruent to the red one, and we also know that this angle here is corresponding to this angle here, right? Therefore, angle MLN equals 25 degrees. You see that?
Yeah.
Okay. All right, then let's see the next judgment theorem. Judgment theorem 2 states that if two sides and angle between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. It is also abbreviated as SAS. That means side, angle, side. You understand? So for example, in the figure on the left, we are given AN equals OB. AN is here. Okay, AN equals OB. And AM equals OJ. AM is here, equals OJ. Also, we know the angle in between the two sides are equal. Angle NAM here equals angle BOJ. Okay, and according to this judgment theorem, we know that two sides and the angle between them in one triangle are congruent to the corresponding parts in another triangle. Then these two triangles are called congruent, right? Therefore, we denote as triangle NAM is congruent to triangle BOJ. Can you see why we should write these three letters in this order? Because,
Yes.
yeah, because B is a vertex that is corresponding to N, right? You see that?
Yeah.
And O is corresponding to A. J is corresponding to M. And if you cannot see it, again, we can rotate this triangle here like this. This is much easier to see, right? And as you can see here, angle O is corresponding to A. Angle B is corresponding to N, and vertex J here is corresponding to M. That's why we write B, O, J, which are corresponding to N, A, M. Understand?
Yeah.
Okay. And also we put SAS here to indicate we reach the congruence by SAS theorem. Okay, any questions?
No.
Okay, sometimes it'll take you a little effort to find the corresponding vertex. Okay, do not confuse the vertex. Usually we have to write the corresponding vertex in this order. Okay, then let's do a exercise. So we are given a diagram below. Point E is a midpoint of both segment AC and segment BD. As shown, then prove that segment AB is parallel to segment CD. Okay, I'll give you a hint. We have already learned that to prove two lines or two segments are parallel by proving that the alternate interior angle that are equal, right? Or you can also prove that same side interior angles are supplementary. Or you can also prove that the corresponding angles are equal, right? You can use either of the four Judgement theorems to determine if two lines or two segments are parallel. Okay, I'll give you 1 minute.
Isn't it because the triangles are like equal to each other?
Yeah, seems that these two little triangles are congruent to each other, right?
Yeah.
And if you can prove these two triangles are congruent to each other, then probably this angle equals this angle, right?
Yeah.
Then we can use the Judgement theorem to decide these segments are actually parallel because these two angles are alternate interior angles, right? So we can use this logic. So the key is to decide if the two triangles are congruent, right? So how do we prove that? So note here, this part equals this part, right? And this side equals this side. So what can we write? We can write because AE equals CE, right? And also we know that BE equals DE, right? And this angle here equals this angle. Also AEB equals CED, right? So we can use Judgement theorem too, because we have side equals side, side equals side, and the angle between these two sides are also equal. So we can use SAS to determine these two triangles are actually congruent. Can you follow me?
Yeah.
So you can say, therefore, triangle ABE should be congruent to triangle. So how should we write the other triangle? So apparently the other triangle is DEC, right? But what's the order of the vertex? So which vertex is corresponding to A?
D.
Why is D? Okay, let me show you something. Again, if I cut this part,
C.
should be C, right? And let's rotate it like this. Then this is easier to see, right? Vertex A is actually corresponding to this one, right?
Yeah.
So we should put C here, right?
Mm-hmm.
Okay, so what's the next one? Which
D.
vertex? B is here, right? B is corresponding to D, so we should put D here. So which vertex in this new triangle is corresponding to E? Of course,
E.
that's E, right? You understand?
Yeah.
A, B, E, A, B, E, then C, D, E, right? We should put the corresponding vertex in order. Do you understand?
Yeah.
Okay, that's what I mean. Sometimes it'll put you it'll take you some effort to find the corresponding vertex. Okay, do remember to write the congruent triangles in this order. Okay, do not write triangle CED or triangle DCE. Okay, please write these vertex in the corresponding order. And okay, because we have these, and then we can prove these two triangles are congruent by using SAS, right? Side, side, angle, side. You understand? So we should put the letters SAS behind your conclusion here to indicate actually we're using SAS to determine these two triangles are congruent. Can you follow me?
Yeah.
Okay, and because we know that vertex A is corresponding to vertex C, right? So this angle here is a corresponding angle to this angle here, right? Because these two angles are congruent, and also A is corresponding to C, therefore we know that angle A equals angle C, right? Can you follow me?
Yeah.
Therefore, because angle C equals angle A, these two angles are alternate interior angles, right? If you consider segment AC is a transversal segment between AB and CD. Therefore, we have proved that the alternate interior angles are equal. Therefore, AB should be parallel to line to segment CD, right? Can you follow me?
Yeah.
All right. Any questions?
No.
Okay, then let's see the third judgment theorem. Third judgment theorem states that if two angles and the side between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. Okay, again, in this figure, for example, if we know that angle B equals angle E, then BC equals EF, then angle C equals angle F. If we know all of these, that means in the left triangle, we know that two angles BC and the side between them, which is BC, are congruent to the corresponding parts in the right triangle, right? And according to Judgment theorem 3, we know that angle ABC is congruent to angle, triangle ABC is congruent to triangle DEF by using ASA theorem. Okay, and can you see why D is corresponding to A? Can you see that?
Yeah.
And D is corresponding to B, right? Be careful, it's not F, it's vertex E that is congruent to B. If you can't see that easily again, you can try to rotate the right triangle. So, well, actually, at this time, we're not rotated, we are flip it. So if you flip it like this, then it is easier to see that this vertex is corresponding to D, right? And vertex B is corresponding to E here, right? And vertex C is corresponding to vertex F here. You see what I mean?
Yeah.
That means if you write these three vertex in this order, A, B, C, you need to write the other triangle in this order, D, E, F. You understand?
Yeah.
Okay, then there is another Judgment theorem. Usually this theorem is very similar to ASA. So first, let's have a look at this theorem. If two triangles and a side not between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. For example, in the figure on the left, if we know that triangle G equals triangle J here, and angle G is equal to angle J here, and angle F equals angle K here, and also FH equals KI. Then we know that triangle FGH is congruent to triangle KJI, right? And also, you should be able to find that F is corresponding to K, G is corresponding to J, and H is corresponding to I. You see that?
Yeah.
So why did I say this is very similar to the previous one? Because if F is equal to K and G is equal to J, we naturally know that actually angle H equals angle I, right? Because the sum of the three angles in triangle is just 180 degrees. You see that?
Yeah.
And then according to the previous theorem, ASA, actually we have this angle equals this angle here, and then this angle equals this angle here. And also we know the side between these two angles are also equal. So according to ASA, these two triangles should be congruent, right? So in essence, Judgement theorem for AAS is actually the same with the previous Judgement theorem, ASA, right? Do you see what I mean?
Yeah.
Okay, there is only one issue you need to pay attention to. When we are using AAS theorem, the equal sides must be adjacent to corresponding equal angles. For example, let's see these two triangles here. The triangles shown below are not congruent because the equal sides are not adjacent to corresponding equal angles. So basically we have this angle equals this angle, right? And we also know that this angle is congruent to this angle. And if you want to use AAS, we know this side is 5. If this side is 5, then we can use AAS, right? Because the side with length 5 is adjacent to 70 degrees, not adjacent to 30 degrees. So if you want to use AAS, these two sides should be equal, right? You understand?
Yeah.
Instead, we do not have that. What we have here is this side equals this side, but these two sides are not corresponding side, right? You see that? Why? You see why?
Yeah.
Because in the left triangle, 5 is adjacent to 70 degrees, and in right triangle, 5, the side with 5 is adjacent to the 30 degrees, so they are not corresponding part. You can only use AAS when the equal sides must be adjacent to the corresponding equal angles. Understand?
Yeah.
Okay, then let's have a look at a exercise. So we're given a figure as shown on the right. PQ equals PR. PQ is here, equals PR. And angle PQY equals angle PRX. So this is a given information. And question A proves that QY equals RX. QY equals RX. So we want to prove this side equals this side. And next, prove XN equals YN. XN equals YN. So first of all, let's prove QY equals RX. Give you 1 minute to think about this question, okay? I'll give you a hint. I'll give you a hint. Usually, if you want to prove that two segments are equal, you can consider using congruent triangles, right? If you can prove that two triangles are congruent, then the corresponding parts should be equal, right? Corresponding sides should be equal. So, any ideas?
Well, PQ equals PR and angles equal each other, so then that means that like
Yeah,
they're
you
equal.
should probably you should prove triangle PQY is congruent to triangle PRX, right? Can you do that? Okay, let me show you the solution and you can check your solution whether it's the same with mine, okay? So as I said, probably you need to prove that triangle PYQ is congruent to triangle PXR, right? Can you prove that? Can you prove this? Okay, so note here, because we have angle PQY equals angle PRX, right?
Yeah.
That means this angle here equals this angle here. And also note that in these two triangles, this is a common angle, right?
Yeah.
So let's say P, angle P. Let's say, okay, angle QPY equals angle RPX, right? And then we have two pairs of equal angles now. And note here, we have also this side equals this side, right? PQ equals PR. Then can we say these two triangles are congruent now? Angle, side, angle. Can you follow me?
Yeah.
So can we say that these two triangles are congruent?
Yes.
Okay, therefore, triangle PQY is congruent to triangle PRX, right? So which theorem are you using here? So what should I put here? The three little letters.
SAS.
Why is SAS?
Oh, no, never mind.
It should be, you have an angle, side, angle, right? Angle, side, angle. So what should I put?
ASA.
ASA, right? So we landed on this conclusion by using theorem ASA. That means two angles are equal, then the side in the middle are equal, and the other angles are equal, right? You see that?
Yeah.
And also, we know that this vertex in the triangle PQY is actually corresponding to this vertex, right? Can you see that?
Yeah.
So let's use another color. So if you flip the green triangle horizontally, then Q should be on top of R, right? And X should be on top of Y, right? That's why R is corresponding to Q and X is corresponding to Y. You understand?
Yeah.
Okay. All right, because we have proved triangle PQY is congruent to triangle PRX, therefore the corresponding angles are equal and corresponding sides are also equal, right? Therefore, we can say QY equals RX because, as you can see here, QY, this side here, in the triangle PQY is just the corresponding part to this side in triangle PRX, right? You see that? Any questions?
No.
Okay, then let's consider the second question. So how do we prove xn here? How do we prove xn here equals yn here? Okay, I'll give you 1 minute to think about it, okay?
Well, because if they're congruent, that means their side is the same length.
Okay. All right, let me give you the solution and you can check whether it's the same with yours, okay? All right, I have a thought that if you can prove this triangle here is congruent to this triangle, then these two sides seems to be corresponding, right? Then if you can prove these two triangles are congruent, then this side should be equal to this side, right? Can you follow me?
Yeah.
Okay, because we have already proved that triangle PQY is congruent to triangle PRX. That's what we have done in the previous step, right? Therefore, we have the corresponding sides are equal, which means PY should equal PX, right? And also, because PR equals PQ, therefore PR minus PY should equal PQ minus PX, right? You follow me?
Yeah.
Okay, so what is PR minus PY? PR is here, PY is here. So what is PR minus PY?
YR.
YR, right?
Yeah.
Okay, and what is PQ minus PX? PQ is here, PX is here.
QX.
So XQ, right? Okay,
Yeah.
now we have YR equals XQ. So let's label it. YR is here. We have YR equals XQ. Okay, that means we have one pair of equal size, right? Can you follow me?
Yeah.
Okay, remember that our task is to find one equal pair of size. Remember our task is to prove that triangle XQN is congruent to triangle YRN, right? Now we have a pair of equal size. And also note that this angle here is equal to this angle, right? Because they are vertical angles. Vertical angles should be the same. Understand?
Yeah.
So can you find another pair of equal elements in these two little triangles?
QN and then I.
This angle here should be equal to this angle, right?
Yeah.
Why? Because we have just proved that this triangle is congruent to this triangle, right? And these two angles are corresponding angles. Okay, and therefore we can say because angle Q equals angle R, also angle XNQ equals angle YNR. Therefore, we have one side, one pair of sides, one pair of angles, another pair of equal angles. Then can we say triangle XQN is congruent to triangle YRN? We see that now.
Yeah.
Okay, what should I write here? If I write triangle XNQ is congruent to triangle, so what should I put here? You see that?
Yeah.
Which triangle? Triangle XNQ is congruent to which triangle? You see that?
Yeah.
Which one?
Um.
So note here, we have proved this side equals this side, right?
Yeah.
And this angle equals this angle, and angle Q equals angle R. According to AAS, is this AAS? Angle equals angle, angle equals angle, and a side that is adjacent to one of the angles. So according to AAS, and triangle X and Q should be congruent to which triangle? Can you see that?
Y and R.
Yes, it should be congruent to Y and R, right? Because the blue angles are equal. Green angles are also equal, and then we have a pair of equal size, which is adjacent to the blue angle. So according to AAS, we have proved that triangle X and Q is congruent to triangle Y and R, and X is corresponding to Y, N is corresponding to N, and Q is corresponding to R, right? You follow me?
Yeah.
Okay, if these two triangles are congruent, then the corresponding parts are congruent, right? Therefore, we have xn equals yn, right? Because xn and yn are corresponding parts. xn is here, yn is here, right? You see that?
Yeah.
Okay, so that's why we can prove that xn equals yn. Okay, any questions?
No.
All right, so let's make a brief summary of the judgment theorems. So far, we have learned 4 judgment theorems regarding to the congruent triangles, right? First one is called SSS. So what does this mean? This means if each side of one triangle is congruent to the corresponding side of another triangle, then we can say that triangles are congruent. Understand?
Yeah.
For example, if we have another triangle, this side equals this side equals this side, and this side equals this side, then these 2 triangles are congruent, right? Okay, the second judgment theorem states that if 2 sides and angle between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent, right? So for example, if I have another triangle here, this angle equals this angle here, and this side equals this side here, then this side equals this side here. By using the second judgment theorem, which is SAS, we can say the triangle on top is congruent to the triangle on bottom, right? You follow me? You
Yeah.
follow me? Okay, so this is called SAS. Next judgment theorem states that if 2 angles and the side between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. For example, if I have another triangle here, this angle equals this angle here, and this angle here equals this angle here, and the side between them is equal to this angle between these 2 angles, then I can say these 2 triangles are congruent, right?
Yeah.
And this is called ASA because A is here, S is between the 2 angles, and then followed by another angle. So this is why it's called ASA, right? Okay, so last one states that if 2 angles and the side not between them in one triangle are congruent to the corresponding parts in another triangle, then the triangles are congruent. For example, if we have another triangle here, this triangle here equals this one here, and then we have another angle here equals this angle here, and then this time we have a side that is not in between but adjacent to the angle here. So note here, these 2 sides must be corresponding. Then we can say these 2 triangles are congruent triangles. So that's why it's called AAS, because S is adjacent to one of the angles, not between them. You understand?
Yeah.
And you can prove this, then you can prove these triangles are congruent. So this is why it's called AAS. Okay, and note here, we haven't learned any ASS or AAA, right? That means ASS or AAA not necessarily means congruence, right? For example, in the figure on the left, there are, if we consider these 2 triangles, first of all, we can consider this triangle here, the purple one, and also we can consider the green one, largest triangle here. First of all, they share the same side here, right? That means they have a S that are equal, and they share the same angle here. That means they have a pair of equal angles, right? But in the purple triangle, this side equals the side in the green triangle here. That means they have another pair of sides. But apparently these two triangles, the purple one and the green one, are not congruent, right? So ASS not necessarily means congruence. And also, if you have a pair of triangles that have AAA, that means the corresponding angles are equal. All of the corresponding angles are equal. For example, in the large triangle, large green triangle here, and we have a red triangle here. As you can see here, all the corresponding angles are equal. This angle equals this angle. This angle equals this angle. This angle equals this angle. We have AAA in this pair of triangles, but it does not mean these two triangles are congruent, right? Apparently the green one is larger than the red one. Therefore, you need to pay special attention here. ASS or AAA does not necessarily mean congruence. You understand? The only four theorems you can use to prove that two triangles are congruent is SSS, SAS, ASA, or AAS. Do you follow me?
Yeah.
Okay, I hope you can make good notes of today's lesson. If not, you can refer to my notes on Google Classroom, okay?